How much time does it take to accelerate from an initial speed of 20 to a final speed of 100 if your acceleration is 1.5 meters per second squared? Every second that goes by, you gain or have a positive velocity increase of 1.5 meters per second. So it's going to take some time to go from 20 to 100. Let's figure out what that time is. Once again, take a moment and circle what we know. Our starting speed, v naught, is 20 meters per second, using red because it's contrasty. The final speed is 100 meters per second. The acceleration is 1.5. Writing the equation, v is v naught plus at. Now, this is a little bit of math. We need to isolate the t. The t is multiplied by the a, and the entire at, product of acceleration and time, has velocity added to it. We have a choice of getting rid of the v or getting rid of the t first, and the answer is to get rid of the v. This is added, so if I rewrite, the opposite of adding vi to at is subtracting. So I'm going to write this, negative v naught plus v equals positive v naught plus at plus negative v naught. What I did was to add v naught to both sides, or negative v naught. So I subtract it from both sides. If it's added to at, I'm going to subtract it. Positive v naught plus negative v naught cancels. So I'll rewrite v minus v naught, just change the order of v and v naught, equals a times t. The problem itself is not difficult, the substitution, but the manipulation of the equation is difficult. Take your time and do it right, and you won't make mistakes. Now we have acceleration multiplied by time. The opposite, if we want to get rid of time, or excuse me, if we want to get rid of acceleration, time and acceleration are multiplied. The opposite of multiplying by a is dividing by a. I'll do that on both sides. Whatever we do on one side, we do on the other. And a cancels. So the time is equal to v minus v naught divided by a. If we do this from a dimension standpoint, let's take a look at the units. V minus v naught is meters per second. A is meters per second squared. Multiply or dividing fractions, we get meters per second times the reciprocal of the denominator, seconds squared, per meters. Meters will cancel meters. One of the seconds will cancel one of the seconds in the squared, and it leaves us with seconds. Wonderful. So time is measured in seconds. Now let's take this equation, because we're running out of room. I'll sub the numbers in up top. Time is equal to Vf, which is 100 meters per second, minus the initial speed, 20 meters per second, divided by the acceleration, 1.5 meters per second squared. Just put that decimal place in there. When we do the math, we get 80 divided by 1.5. And that time, again, we said it was going to be substantial, is, pull this out a little more, 53 seconds. So that velocity change requires almost a minute because the acceleration is so low.